Students, in the last session we have seen the introduction about isometric projection and geometrical construction involved in isometric projection. Here in this session we will try to solve problems on isometric projection using isometric concepts that we discussed in earlier session. So first problem, draw the isometric view of hexagonal prism. B is pentagonal prism of base side 25 mm and axis height 50 mm when it's less on one of its ends on the HP with one of its base sides parallel to VP. So one of its base side is parallel to VP. So orientation, you should be very careful. Draw the orientation like this. So this is one of its sides parallel to VP. Now it is hexagonal prism. So that is the first part, and 25 mm side, and I am naming them top surface. Top face is given A, B, C, D, E, F, and bottom face are named with the P, Q, R, S, T, U. And this is the base. I have enclosed this within the rectangle 1 2 3 4 rectangle. And now from center draw the axis, and the height is given 50 mm. Height is 50 mm only. So with 50 mm draw the prism. So this is the front view of the prism, and give the notations as usual we did in the projections of solids, right? So after giving notations with this orientation, right, from starting from one corner, right, this is my one corner, and from here start projecting this prism. So from 1 towards 2, measure 1 to B, this distance 1 to Q actually, right, 1 to Q, and mark that point. So once you mark that point, right, 1 2 3 4, and this is the center point for P. So P is a center point, and this is Q here. Once you measure Q, you can draw parallel line and you can measure U, right? And the same distance can be measured here, and you can mark the point R. So 2 towards 1, you can mark R, right? So this is R. You can draw now parallel lines. So obviously this is opposite point, and you can draw a parallel line and you can mark the S, point S. So this is, you can draw a parallel line and you can mark T. You can draw a parallel line here and you can mark U. So like this you can once you mark one point, obviously the another point also you can get with the same distance that already you measured. So like that you can save the time. So now the bottom face I have marked all the points. Now I have to get the top face. So given height is 50 mm from any corner, right, from this corner I have taken 50 mm, and you can start doing that from each and every corner, right, 50 mm. Now if you join this, right, 4 corners, you will get the top rectangle. This is the top iso rectangle, and from each point, right, you can project onto this rectangle. So you can be projected and you can get F, point F. P can be projected and you can get a point A, and Q can be projected parallelly, right, and vertically. So you can get B, C, D, E, and F, right? So all the points you can get on the top face like this. Very simple problem. And from as I said earlier, right, you can measure, you can mark with thick lines. Whatever points you have on the top surface, those can be marked with thick lines straight away, right? No need to think for any invisible edge here, right? You can connect here the top face. So it is the isohexagon, right? So now outermost points you connect, F to U, so U to P, P to Q, Q to R, R to C, right, and F to U should be drawn thick line, A to P should be drawn thick line, B to C, B to Q should be drawn thick line, and C to R should be drawn thick line, right? So no need to connect a T to E as well as S to D. These two can be left, right? You can leave them, no need to connect them, right? So this is the standing hexagon. So now part B in this question is pentagonal prism of base height 25 mm, right? So pentagonal prism is 25 mm, and here also with one of its base sides parallel to VP. So this is the parallel to VP base side, and you should maintain the same orientation in pentagonal prism also. So rest of the procedure is same, right? Rest of the procedure is same, and now this is the parallel edge to VP, parallel edge to VP. Now same procedure should be adopted here, and now if you project it, right, you will be seeing pentagonal prism like this. So mark all the points, and same procedure you adopt here, and you can get the isometric projection, isometric view, right? It is view only, so no need to use isometric scale. Now the bottom is also connected, and here to this is the isometric view of pentagonal pyramid when one of its base side is parallel to VP, right? So same procedure should be adopted here to get a pentagonal prism. So next problem is draw the isometric view of cylinder and cone of base diameter 60 mm, axis length 70 mm when it is resting on its base on HP, right? So cone and cylinder should be drawn. So only one method you should recall and adopt here, that is known as 4 center method. So this is the first is cylinder. So this is cylinder front view on top view. It is very simple. Draw the 4 center method. Alright, here half 4 center method can be used, and you can draw the cylinder. Same way you can complete the pyramid. This is the pyramid, right? So only apex should be drawn, and the center point, right? Center point. So or you can measure the center height, and you can mark this apex also. That way also you can do this, and this is known as box method. It is box method. And the third question, draw the isometric projection of A part is hexagonal pyramid, B part is pentagonal pyramid of base height 30 mm and axis length 60 mm. When it rests on its base with one of its base side perpendicular to VP. So one of its base side is perpendicular to VP. So orientation you should draw carefully. You should draw a perpendicular line to XY reference line, and you should draw the hexagon, right? It is 30 mm, and this is the front view and top view of hexagonal pyramid, right? When it's one of its base edge is perpendicular to VP. So now you take this point as reference, draw 30-30 plane. 30-30 plane, it is given as isometric projection, so use the scale. So this scale should be used, and this is 1.1, right? And this is the center line. So you can draw the center line. You can get F and C, and you can get B and A on 4-1 line, right? 4-1 line, A, B, C, D, E, F, right? All points are obtained here. Now this is the center. From here you can measure the height. You can measure the height, right? So you can draw the outermost point should be connected. Now O to A should be connected, and O to B should be connected, and O to C should be connected. O to E no need to connect. You can leave as it is, right? So this is the isometric projection of hexagonal pyramid. Now we will see isometric projection of pentagonal pyramid. So that is there also all dimensions, right? All dimensions are reduced to iso value, right, using this scale. So same practice should be adopted in 3B also. So this is the front view and top view, simple front view and top view. So once you get simple front view on top view, draw the iso scale and start projecting. So measure each, right, convert every dimension, given dimension to iso value, use that here, right. So for example 1 to 2, measure here and convert here, that should be used here, right. So similarly you have to convert all the dimensions, right. So now this is the pentagon base points and this is the center point. From here you can measure 60 mm, right. 60 mm should be converted, it is converted dimension. And now connect O, right. O should be connected to A, and O should be connected to B, O should be connected to C, right. No need to connect E, right. So this gives you the isometric projection of pentagonal pyramid, right. So this is the way to construct the three-dimensional view of pentagonal pyramid. So fourth question, a hexagonal prism of base edge 25 mm and height 50 mm rests on the HP on its base with two of its rectangular face perpendicular to VP. It is cut by a plane inclined at 30 degrees to HP and perpendicular to VP at a distance of 40 mm from its base. Draw the isometric view of truncated prism. So obviously when the cutting plane is inclined to HP, the retained portion obtained here is known as truncated portion. So obviously a prism here, it should be a truncated prism. To start with, draw the front view on top view. So this is hexagonal pyramid, right, prism, right. This is hexagonal prism, and at 40 mm the cutting plane meets the axis at 40 mm from its base, right. Mark the cutting points. So here you have two edges and you get 2 points here, and whereas here 2 points, whereas here two top face edges, so you will get 2 more points, that is EF and DC, right, DC. So again you get 2 points. So mark points, cutting points PQRS and TU. So here P is on BH and Q is on AH. Similarly, R is on CH, S is on FH, and T is on visible edge. So that is the base edge BC, and U is on EF, right. Totally 6 points. You can mark them here, right. This is TU, and you have 1, 2, 3, 4, and now these points should be projected here, right. These points should be projected here. To project T and U should be projected from top view, whereas PQRS can be projected from front view, right. That is the distances you can measure and you can mark them vertically, whereas U and T should be measured from base, right. Or you can measure it on the top what you call rectangle, also top rectangle. So anyhow you are marking the rectangle, anywhere you can mark and you can get T and U. So this is one is here, and mark this rectangle 1, 2, 3, 4. Now complete the box. So this is the box for this prism, right. So now this is the box method. This truncated prism I am going to enclose within this box. I am going to keep that in three-dimensional view within this box, right. So this is my point A, and I will get point B here. I will get point C, center point. So if you project it, you will get point D, right. If you project it, point E, and this is F, right. So base points I have obtained. From A to top rectangle you can project, and this is again A, and B, C, D, E, F, right. I will get all the points on the top surface, right. So up to here the procedure is normal, and now you have to measure each and every point, cutting point, right. You have to mark cutting points. So you have P, right. P is on BH, right, on BH. Q also at the same distance from on AH, right. On AH you have Q, right, point Q. On BH, right, you have P, right, point P, on C edge. So this is the C edge. On C you have point R. So measure this distance, vertical distance, and mark on this C line, right? So that gives you R, right? So to measure and mark U, right? So on this line, 1 2 line, you can observe this distance, right? This small distance, right? So that can be marked here, that can be marked here. And now this distance, this vertical distance, on this line you can mark that point, right? So that point, so this is your point T, right? Point T. So the height is 50 mm. From this intersecting point you can measure 50 mm and you can mark point T, right? T. Otherwise you can do like this also, you can measure directly here and you can mark T. That is also fine, that is also correct. So here also you can draw that small rectangle and you can mark the U, right? So that way you can do. Otherwise you can get each and every point from base, so that is also a good practice. So this is U, right? So this is your S, right? Your S, point S. So now connect outermost points with thick lines. So A to B, B to C, C to D, D to D, and D to E, E to uh, E to U, U to S, S to Q, and Q to A, right? So this is the outer line I have drawn, outer line. Now I have to show this cut surface, this cut surface. Now this is the cut surface Q to P, right? So P to R and R to T, T to D, right? This is the cut surface. Now vertical edges are visible here, P2. So this is the top portion, so this much portion, so this portion is visible like this. And now R2 P2B is visible and R2C is also visible. So this is the final truncated prism I have obtained. So the same way you should draw the, you should project the truncated prism. So this problem, right, is a very important problem, and you can connect and see how interestingly you get this three-dimensional projection. It will be very interesting and also very easy, right? So this is the truncated prism now. So next is question number 5. It is pentagonal prism. It is projection. Earlier we have drawn the what you call isometric view, whereas here the projection is asked. You have to draw the isometric scale and you have to draw isometric projection only. So it is a very same, say similar problem. It is pentagonal prism, right? It is pentagonal prism. Mark the cutting points, and same way you should project them and get all the points. So I am getting the cutting points here. 1 is on A, 2 is on B, 3 4, right? 3 4 are on the top surface, and I should draw the rectangle as we did in the earlier problem. And 5 is on D, and 6 is on E, right? So now start doing this. All the dimensions, right? All the dimensions should be converted into ISO value here. So once you convert it, you will be getting a smaller one than the usual rectangle, right? So now this 1 to 2 should be converted here. Not only this, all the dimensions whatever you have in this front view and top view, all the dimensions should be converted, right? Should be converted. And this is 1 to 2, 2 to 3, 3 to 4. Now draw the box as we did in earlier problem, and mark A. So this distance, measure this distance, convert here and use that here, right? 1 A, and you have B, C, D, E, right? So totally 5 points. Now all those points you get on the top surface also, right? So now you measure this one distance, right? From front view you measure one distance, and from here A to A line you mark 1, right? So on B line you mark 2. So this vertical distance should be measured here, that is converted here, and that distance, converted distance, should be marked here. So 2 and point 3, you draw this rectangle here, draw the rectangle, and from intersecting point you measure this height, right? So this height is 70 mm actually, so that should be converted and that height should be used. So this is point number 3, right? Point number 3 and point number 4 can be obtained in similar fashion, and 5, 6, totally 6 points. Now connect outermost points with thick lines A to B, B to C, and C to D, D to 4, right? D to 4, and 4 to 5, and 5 to 6, and 6 to E, E to A, and here this is the outer lines connected. Now you have obtained the skeleton, and you have to mark the inner points, right? So start them, and 6 to 1, 1 to 2, 2 to 3, and 3 to C, and 3 to 4, right? And here 1 to A should be drawn thick line, 2 to B should be drawn thick line, and 3 is here, right? No need to draw any line for 3. So this is the final isometric projection, right? It is projection of this truncated prism, right? Truncated prism of pentagon base shape. This is problem number 5. Sixth problem, it is pyramid, and isometric view we are going to draw. A pentagonal pyramid of base height 30 mm and axis length 65 mm is resting on HP on its base with a side of base perpendicular to VP. It is cut by a plane inclined at 30 degrees to HP and perpendicular to VP, right? So 30 degrees to HP, you will get the truncated solid, and passes through a point at a distance of 30 mm from the apex. Draw the isometric view of the remaining portion of the pyramid. Isometric view only should be drawn here, right? And this is the front view on top view, and enclose this top view within box. And now cutting plane is meeting at 30 mm from the apex, and it is 30 degrees, right? All the points you connect in top view, right? This is one is on AO line, right? AO line, and 2 is here, 2 is on OB line, 3 is here on OC line, right? OC line, and 4 is here on OD line, and on OE line you have point number 5. So totally 5 points you have here, and these are the cutting points. These points you can project it onto top view, right? And this rectangle method you can use, and from here, right, this height can be measured, and that height can be used to draw the point, to mark the point. So that way you can easily complete, right? So you mark the base points. So this is A, B, C, D, E, right? And here you have 1. So draw this rectangle with reference to 1, right? Draw this rectangle with reference to 1, and this is 1, and you project here, right? This is the 1 point, 1 base, and this is point number 1, right? Similarly for point number 3, right? Point number 3, right, on B, right, you can measure and mark point number 2. So it is 2, point number 2, right? Point number 2. So this distance can be used, or you can use this distance from 2, 3 line. The way, any way you can do it, right? And point number C, on C you have 3. Measure this distance and mark here, and vertical distance you measure and mark vertically to get point 3. So this is point 3. So this is point 3. Similarly you get point 4, right? Similarly you get point 4, and you have a point 5 also, right? Point 5 vertically, and now join this top surface first, right? Top surface. Now 5 to E, it should be thick line, right? and E to A should be thick line, A to B should be thick line, and B to C, B to 2 should be thick line. C is visible here little, right, like this, and you should connect C also like this, and 1 to A should be thick line. So this is the isometric view of truncated prism. This is the isometric view of truncated prism, and this point should be projected from this base rectangle. That should be done very carefully. So once you get the points height should be measured from front view, and that base point should be measured and marked from top view. So this you have to remember in this problem. So this is the problem number 6. In problem number 7, it is hexagonal pyramid, right? When it is resting on its base, right, on the HP with the two sides of the base parallel to VP. So this is the front view on top view. So these are the two base sides which are parallel to VP. It is a hexagonal pyramid, right? Hexagonal pyramid, and this is the frustum of the pyramid. So cutting plane is passing through, right, through the pyramid parallel to HP, right? It is frustum. It is very simple problem, very simple problem, and frustum height is given 55 mm. 55 mm. The top hexagon is 10 mm side, and bottom hexagon is 30 mm side. So you should get the height, you should get the front view from top view only, right? So you project them and get the points here, right? You have two hexagons, and now complete the front view like this. So this is the front view on top view. Now enclose this within rectangle, and now one more rectangle for this smaller hexagon, right? One more rectangle is rectangle for this smaller hexagon. Once you draw this front view on top view, the isometric view is very simple to project. So this is point A, B, C, D, E, right, up to F, right? So this is the center point. From this center, you project onto with this height, 55 mm height. So now this point as center, so this is the center point. Now measure this distance as well as this distance, and you can draw those two lines parallel to 30-30 line, right? So this is, and this line, you can draw a line here, and that is this line, and this line is nothing but this line, right? So this vertical line G to J is this distance, and from here to here this distance. Now you draw parallel lines, right, and complete this rectangle on top. Once you complete this rectangle, your work is almost done, right? Now you can mark G. G is straight away obtained here, and H is measured and marked. H and I should be measured and marked here, H and I, and the opposite point J, and for this you can get the K point, and you can get L point, right? L point. So now all the points you have obtained. Now connect this with thick lines straight away, right? Top surface you connect them with thick lines, right? Thick lines. Now L to F, right? L to F should be drawn thick line, F to A should be drawn thick line. Now G to A should be drawn thick line, H to B should be drawn thick line. So this is the frustum now, right? It is the frustum of the hexagonal pyramid, and a very easy problem to draw this, right? Very easily you can complete this. This is problem number 7 and 8. It is a cylinder of base diameter 60 mm and height 70 mm, rests with its base on HP. A section plane perpendicular to VP and inclined at 45 degrees to HP passes through the axis at a distance of 50 mm above its base. Draw the isometric view of the truncated cylinder showing the cut surface. So cut surface only should be drawn here. It is a cylinder. It is a cylinder problem, and the truncated cylinder should be projected as isometric view only. So to start this problem, draw the cylinder, divide this cylinder into 12 equal parts, right? Draw the front view of the cylinder and cut the cylinder right at 45 degrees, right? So mark the cutting points. One is on A generator, 2 is on B generator, 3 is on C generator. Similarly, you mark the cutting points. So here up to E generator, right, up to E generator you have on vertical generators, right, and then you have two more cutting points, point number 6 and 7, right, point number 6 and 7 are here, right, on the horizontal surface, so those 2 points should be projected and drawn, and 4 remaining points, right, should be drawn here, right. So totally 11 points I am getting here. All these 11 cutting points should be projected to show the cut surface. It is obviously truncated surface. So enclose this within square. Now draw the square. This is the rectangular box, right, and mark all the points, right. So here you can use the point A here, right, point A, and this is the point 1. 1 is here on one A generator, so this is point 1, and you have point 2 on this generator, B generator, right. So this is point 2, and point 3 is obtained on C generator. So now you concentrate on only points. The base can be connected with 4 center method, right. So 4 center method can be used, and mark all the points vertically, right. So this is point number 6. 6 is drawn with a rectangle. So this is the rectangle, and this is the rectangle, right, this is the rectangle, and this is the rectangle for 6 and 7. So 6 and 7 is obtained, and this is point number 8, and 9, 10 and 11, right, totally 11 points. Now I have to connect all these points with a very smooth curve, right, very smooth curve. So this is the between 7 and 6 you can use 4 center, right, you can use 4 center method, you can use compass. So use the partial 4 center method here between 7 and 6. So then you connect all these points with a smooth curve, right, with the freehand or French curve you can connect with the smooth curve, right. So I am using 4 center method, right. So now with the 4 centers I am going to draw at the base also between point A and here, right, here, and I can project up to here, right, up to 11th point, right, I can project it, and to draw between 7 and 6, remember 7 and 6 should be drawn with the 4 center method, right. So using this center you can draw from here to here. Now using this center from here to here, right, here to here. So using 4 centers, and only 2 centers I am using to draw this partially, right. Once I do, right, I can use 4 center method at the bottom, and I can draw the smooth curve. So now 11 to here should be connected, and point number 6 to here should be connected, and this should be drawn with thick line, right. So this is the truncated cylinder. Otherwise you can use points method, and you can draw the base also. Here also you can use points method, and you can use this partial circle. So that way also you can do, nothing wrong. So any method you can use, no problem, but you should get the truncated prism perfectly. So that is very, very important. So this is question number 8. So question number 9, it is cone of base diameter 60 mm and height 65 mm rests with its base on HP. A cutting plane perpendicular to VP and inclined at 30 degrees to HP cuts the cone such that it passes through a point on the axis at a distance of 30 mm above the base of the cone. So it is also a truncated cone you are obtaining here, right? A truncated cone. Draw the isometric view of truncated cone showing the cut surface. So draw the cone, divide this into 12 equal parts as we did earlier, right? Now draw the front view and top view, enclose this within a square, right? Mark the cutting points. So all the cutting points are on generators, right? So this vertical distance you can measure, right, from horizontal point. Now mark that cutting points 1, 2, 3, right, and you can mark the cutting points. Now this 4 and 10, right, should be projected onto this generator, slant generator. So from here to here it should be drawn a thin line, and now this much as radius from center to this much, right, you draw the arc. You draw the arc on both sides, right? You will get point number 4 here and point number 10 here, right? So remaining points there is no problem, you can get on the generators straight away, right? So now we enclose this within box, that is obviously a square, and draw 1 2 3 4. This is 1, and this is center, and this is center line. On center line, to get point number 1, measure this distance and mark vertically, right? So a to 1 you mark the distance, and vertical distance you measure from front view and mark here. So this gives you 1. Similarly point number 2, so point number 2 is here. Draw the vertical horizontal line, right? You can mark a horizontal line, and point 2 should be measured from front view, and vertical distance you mark and get the point 2. Similarly point 3, 4, 5, and all the points you can measure and mark, right? So you can use 4 center method for base, and remaining points should be marked, right? So remaining points should be marked. So this is point number 7. Point 7 is on this generator, extreme generator. You can complete the cone and you can mark 7. Otherwise you can adopt the same procedure and you can mark the 7. Anyway you can do, no problem. 8 and 9, 10, right? 11 is on extreme generator. Sorry, 11 is on not extreme generator, and mark the points and connect this with a thick arc with French curve, and from for to this ellipse, right, elliptical surface, draw the tangent to connect this, right? On both sides you can connect. So this gives you the truncated cone. So base can be projected using 4 center method, right? So partial 4 center method can be used and that can be projected. So this is how you should draw the truncated cone, right? Getting these points you should do from base, right? Horizontal distance you measure, and vertical distance measure from front view. Horizontal distance measure in top view, vertical distance measure in front view. So that is how you should proceed in this problem, and complete the problem. Draw the arc, very fine arc, and you will get the perfect truncated cone. So this is problem number 9. 10, right? A combination of solid is formed as follows. It is combination of solids. A frustum of cone 25 mm top diameter. It is frustum. It is frustum of cone. Already we have used this frustum of cone to draw our first angle projection symbol. A frustum of cone of 25 mm top diameter, 50 mm bottom diameter, 50 mm height is placed vertically on a cylindrical block 75 mm diameter and 25 mm thick, such that both the solids have the common axis. So the top, right, the top cone, frustum of cone, is centrally placed on cylindrical block. Draw the isometric view of the combination of this solid. So again it is very simple problem. Only 4 center method you have to use to draw this, right? It is again a very simple problem. Even though you have two solids, you can easily complete this. So this is the cylinder and cone. These two circles forms the frustum of cone, and this circle is the cylinder, right? Now draw the front view, and this is the cylindrical block, and on this you will have the frustum of the cone. So you have three circles. This is the base circle of the cone, and this is the circle for cylinder, and this is the top surface with the small circle. So three circles you have to draw, right? So you can use 4 center method very comfortably. You can draw this, right? So this 25 mm height should be taken here, and you should draw the top box. So this is the box, right? So on the from the top box you mark the center point, and from center, right, from center you measure 50 mm, right, 50 mm, and mark the top box. So it is the top box, right, top box. Now use 4 centers and draw the circle for this circle can be drawn directly here without any hesitation, right? Without any hesitation, draw the 4 centers for this, right? And this, and 4 more centers for the bottom, right? So now this is the square, right, for bottom of the cone, right? Bottom of the cone should be placed on this rectangle, right, on this rectangle. Now with 4 centers draw the partial circle, right, and now connect it. Now you can directly obtain the frustum of the cone. Now it is cylindrical block, right? So use 4 centers, right, use 4 centers and draw the top surface of the cylindrical block. So now from here you can drop down, right, you can drop down and use 4 centers here again, and draw the semicircle, right, semicircle, and draw the tangent to this circle. So this gives you the cylindrical block. So very easily you can draw this, right? Only 4 center method, no need to mark any points. Directly you can obtain the combination of solids here. So you should connect it very carefully, right? You should connect, you can draw the using 4 centers, you can connect up to this vertical generator of the frustum of the cone. So this can be drawn very easily, and please practice this. It will be a very interesting problem. So problem number 11, 3 square rods of 30 by 30 cross section. So cross section is given 30 by 30, and you have 3 square rods of length 100 mm, right? Lengths 100 mm, 100 mm and 60 mm. So 2 square rods with 100 mm length and 1 square rod is 60 mm are so nailed together that they form the letter H, right? So H letter, the horizontal member, right, can be 60 mm length but with the same cross section, and 2 vertical members with 100 mm length and with same cross section. So draw the isometric view of letter H. So now with these 3 square rods we are going to form letter H, right? And this is the hand drawn diagram of letter H, and this is the square rod with 60 mm, and this is the square rod with 100 mm, right? So square rod, the side is 30 mm square only, right? So now 60 30, right, 60 plus 60, the total width is 120 mm, right, 120 mm. So this should be projected again. It is a combination of solids only, right? So a combination of solids. So enclose this within box, right? Draw the square like this. So this is the 120 mm and this is 30 mm, right? 30 mm. Now draw the only use thin lines. Don't use thick lines right now. And height is 100 mm. So from one draw 100 mm line, and from here also you draw 100 mm line, and draw the top surface straight away, right? Draw the top surface straight away. You can draw the thick lines, and now this member should be projected, right? at 120 mm, draw this line, right? Now draw the vertical lines and complete this vertical member. Now this is one vertical member, this is another vertical member. So in between, right, in between, from here to here, this height should be measured. So from here to here should be marked, right? From here to here it should be marked. On the other side also, right, on this side, this line also, right? So two lines are marked here, right? And this is the first member. So draw thick lines. Now all visible edges should be drawn with thick lines. Now we have done the skeleton, and select whatever line is visible with thick line. So this is now one side, it is completed. Now from here to here thick line, and here to here thick line, and remaining portion should be drawn with thick line. So this should be drawn with thick line, and this is the vertical member, and this is the visible surface, right? Visible surface, and this should be drawn with thick line, right? Only this part, this much is visible. And now this is the H member. It is very easily you can construct, right? You have to measure this distance very carefully. Once you mark this, the remaining portion you can mark very easily, right? On 30-30 plane you are marking this, right? So this is how we should project the H letter. Next is a dustbin. Dustbin problem. A dustbin is in the form of a frustum of hollow square pyramid with the base dimension of 20 mm sides and top open surface of 45 mm sides. Draw the isometric view of the hollow dustbin if its height is 50 mm and the wall thickness is negligible. So dustbin is frustum of square pyramid. It is inverted square pyramid. You have to draw inverted square pyramid. So this is the hand drawn diagram, front view and top view. So this is the small square, and this is the bottom square, top square. Top square is 45 mm side, and bottom square is 20 mm side, and the height of this frustum is 50 mm. Height of this frustum is 50 mm. Now it is inverted solid. Very easily it can be drawn. So from so draw the small square. Draw the small square, and from center you measure the distance 50 mm and draw this box, right? With reference to this, you draw these two lines. It is obviously square, and then complete the parallel lines, and you can get the top square. Now top square is the as it is, right? You can draw thick lines for top square, and bottom square is drawn only up to here, right? So this should not be drawn thick lines. So now complete this. So how easily you can complete this, right? So it is very easy problem to solve. So this is the frustum. This is the frustum, and inside you have a line, and you can leave it, right? Even if you don't draw that thick line, well and good, right? So this is the square, right? Square. Since thickness is neglected, so this line should be shown, right? And this is 12th problem. 13th problem. A cylinder of base diameter 30 mm and axis length 50 mm is placed on its base centrally on the top of a square slab. So you have a square slab and you have a cylinder, right? And slab of side 50 mm and thickness is 20 mm. Draw the projection, isometric projection of this combination of solid, right? A cylinder is placed centrally on a square slab, right? So the front view and top view is drawn here. Front view and top view, and this is the cylinder, square prism. This is square prism. Draw the square prism, and then draw this box, right? Enclose this circle within a square. So that square can be obtained here. So from here you can use 4 center method, and you can draw the top surface, and use 4 center method and draw this circle first, and then draw the 4 center method at the base and connect it. And now this should be drawn with thick lines, right? Thick lines. The only visible edges should be drawn with thick lines. So that is the another problem, right? Combination of solids. A hemispherical vessel of diameter 90 mm is placed centrally over a cylinder of diameter 60 mm and height 75 mm, which in turn is kept centrally over a square prism of base side 80 mm and height 20 mm. Draw the isometric projection of given position of solids. So here you have hemispherical vessel, right? It is a sphere, it is a semicircle you should draw, centrally placed on cylinder and that in turn kept on prism. So you have three solids. So the front view on top view of this combination of solids is a hand drawn diagram here, and this is the front view, right? This is the front view and this is the prism, right? This is the prism, and on that prism you have a cylinder. On that cylinder you have hemispherical vessel, right? So this is the combination of solids, and this is the cylinder is not visible, that's why it should be drawn with dotted line, and some part, right, little portion of this prism is also not visible, and that should be drawn with the dotted line. So once you complete this, it is also very simple problem, very easily you can draw, and only thing is you have to do is for this circle, for the semicircle, you have to use the same radius, right? Same radius to draw this circle. So I will tell you how to draw that. It is the projection. It is the projection. Even though it is projection or view, right? This should be drawn with the compass only, with the given radius. So this radius should not be converted. So whatever way you see the sphere, right, in isometric view or projection, it looks like a circle only. So that should not be converted. So this is the converted dimension, right? This is the isometric scale I have used. So now we are drawing the isometric projection. So this is the block, say the prism, right? Prism. On this prism, draw the this circle, right? This within this, right? You draw the circle, you draw the square for this circle, right? Now with given height, draw the one more circle on the top, right, to accommodate this circle, right? So now this is the cylinder. Within this square, within this surface, you are going to draw the cylinder. So now this is the center point. From this center point you measure the diameter, right? You measure diameter. So this is the iso radius. So whatever radius you have, right, you convert into iso radius, and from this center you mark the center to draw the hemisphere, right? That is the semicircle, right? So use iso radius and mark the center point. Now this point as center, use the actual radius. So this is how you should proceed in this problem, students, and you should be very careful. And to measure from here to here, it is the iso radius of this, right? Iso radius of this circle. So this is how much? It is 90 mm, right? It is 90 mm, and this is 45 mm is the radius. That 45 mm should be converted to iso value and should be measured here. Now take this as center, actual 45 mm as radius, right? Actual 45 mm as radius, right? So actual 45 mm as radius. So this is the iso diameter now, right? This is iso diameter now. So using 4 center method, right, you this is the this top surface of this is hemispherical vessel, right? So draw the top surface, and to draw this portion, right, use this method. Now take this as center, right, and actual radius as radius. The actual radius is 45 mm, right? and tangentially to this circle you draw this semicircle, right? You draw this semicircle, right? You draw this semicircle, and for this, right, so this is the semicircle and that should be drawn with the actual radius, right? So this is the actual radius, true radius, right? And iso with iso that is the four center method, you draw this circle and on this you are placing this hemispherical vessel. So now this is your cylinder, it is your cylinder and this is your prism. So this is how you should proceed, right? So first from this center you measure iso radius. So using this iso radius, complete this iso with iso diameter, you complete this circle, right? So this is the iso circle. So to draw this arc, right, to draw this arc, use true radius. Now this point as center, use true radius as radius, tangentially you draw this circle, semicircle, and then complete this with usual procedure, and this is your base. So this base is obviously a prism. So this is how you should draw this combination of solids. When you have hemispherical or sphere, when you have sphere surface, right, when you have sphere, this is the procedure to adopt, right? So center point should be marked with iso, and then the actual sphere should be drawn. Even if it is a actual sphere, you can complete the sphere directly, right? So without drawing this ellipse, right? So for spherical surface, this is the procedure you should follow carefully. So this is how you should complete the 14th problem. So there ends the problems, all the types we have covered here. You try to practice as many as possible. You will be very comfortable, and it is very interesting topic, very easy topic. You can easily score marks from this topic. So there ends our isometric projection. In next session we will start the freehand drawing or orthographic projection. Thank you students.